Okay, great news here. Problem 16 on the trigonometry review is the last question. Here's the last question. It covers vectors, and it kind of pulls in a whole bunch of vector stuff into what really works out to two problems. You're given two vectors. The first problem, you're finding the component of u along v and the projection of u onto v. Two very simple equations and computations. To really wrap your head around it, though, you probably want to go back and look at some of the videos online about the component of u along v, the projection of u along v. If you've had some physics, maybe you've done some of this stuff because it comes up in finding work value equations and whatnot. But what I want to do is just show you exactly what you need to get through this problem as quickly and simply as possible. And if you want to understand it deeper, by all means, I want you to go look at that material. I'm going to try to find some more material and get it put up on Canvas. Maybe I'll do some videos that describe each of these things in detail, and we can go from there. But right now, I'm just going to get you through this problem. So let's start with the component of u along v. And it can be written this way: component, this means the u along the v. Okay? And what does that mean? Well, let's take a look at this equation. And it's actually a very simple equation. It looks complicated. But this basically says, look, take this thing, which is something called a dot product of u and v, and simply divide it by this thing here, which is magnitude of v. Think of it as the length of that vector. Each of these vectors, for instance, this vector 2, 4, this is all this vector is. So if I ask for the magnitude, actually I'm just looking for this length. That's Pythagorean theorem, right? Use the Pythagorean theorem on the points 2 and 4, and you're going to get the magnitude of this line. You're basically going to get the hypotenuse, right? That's all that is. That's all this is. Now, dot product, what's a dot product? Well, a dot product of u and v, here's u right here. Or no, that's not u. U is negative 2, 8. V is 2, 4. And the dot product, we just take the first two in each one, the negative 2 and the 2, and we multiply them. We take the second two numbers, we multiply them, and then we add them together, and we end up with a number. So the dot product results in just a scalar number. Okay? The magnitude, I said Pythagorean theorem, 2 squared plus 4 squared. We're going to take the square root. We end up with the square root of 20, or 2 square roots of 5. So, if we go back to our original formula, the dot product here, let me scoot this up so you can see it. Go back to our original formula. We calculated dot product was 28. We calculated the magnitude as 2 square roots of 5. Therefore, that simplifies to 14 square roots of 5, which is 14 times square root of 5 over 5. And that's just rationalizing the denominator. And this is it. That's the component of u on v. Really not too hard. You're doing this kind of dot product math, which is two multiplications and an addition. You're doing the Pythagorean theorem, and then you're just doing some simplification. That's all there is to find the component of u along v. Again, if you want to understand, what does it mean, and why are we calculating it, we'll go back. I'll make some other videos in that section of the curriculum, and you can dive a little deeper in there. Let's get on to the projection. Once you calculate the component of u along v, then calculating the projection is pretty straightforward, because what we do is to find the projection, we take the component. We've already calculated this in that previous problem, and we multiply it times the vector v divided by v's magnitude. We've already calculated v's magnitude, so we've got this. We know this. It's given in the problem. We know this. So we really just put all those things together. Here's the component of u on v. We calculated that previously. Here is our v vector, 2, 4. Here's the magnitude. We calculated that in the previous problem. And now we're just going to crunch this out. keep in mind that really when we're done multiplying this and this 1 over 2 square roots of 5, we're going to get a number, and then we're just going to distribute it over these two numbers. That's all we're going to do. So that's not super complicated. Here we go. The square roots of 5 cancel out. So you end up with like 14 over 10. 5 times 2 is 10. Remember, we're going to leave this for last. This just comes down here. 14 tenths is 7/5. So we get 7/5 times the vector 2, 4. We're just going to do a scalar multiply, and we're going to distribute those two things, and we end up with 14/5 and 28/5. And it's actually, if you remember those formulas and how to calculate a magnitude and a dot product, then this last problem on the test is actually very quick